we cannot express y in terms of x. That is why this relation involving x, y is in implicit form. Now we have to find the differential coefficient of derivative dy dx. 3a into ddx of xy, that means ddx of product form. Then in case of product form, that is say u into v, ddx of uv will be equal to, you have learned earlier in class 11 standard, u dv dx plus d du dx. I apply that. In the last episode, I discussed two rules of derivatives. Those are included in class 12 syllabus. Today I am going to discuss remaining three rules. First of all, rule 3. Welcome to btosacademy. Welcome to my maths class. Rule 3. Actually, for the implicit function, we use this rule. First, let me clarify implicit and explicit function. If from a given relation involving two variables x and y, we can express y in terms of x, generally we do that, or x in terms of y, then we say y is explicitly expressed in terms of x. If we can't do that, that means for the given relation, equality relation rather, involving x and y, we cannot separate y in terms of x or x in terms of y, then we say that that form is implicit form. And if we express y in terms of x or x in terms of y, then we say y is explicitly expressed in x or x is explicitly expressed in y. Now, in case of implicit function, I write that form in this way. Expression involving x and y, that is expressed by fxy, that is equal to c. Since f or fxy is not explicit function, then what is the way of finding dy dx or differential coefficient of y with respect to x? The process is simple. We just differentiate the given relation involving xy with respect to x and apply the laws we have learned earlier. That means different form for standard functions, also differentiation of sum or difference of two functions, or differentiation of product of two functions, two or more functions, then differentiation of quotient form, that means ddx of u by v, and also we have learned earlier for class 12 logarithmic differentiation of a function of function. We shall apply these things already learned earlier. Now we just differentiate both sides with respect to x. That is the main thing. differentiating both sides with respect to x. Following that, we apply the laws or rules of derivatives learned earlier and arrange to get dy dx. This is the method. This will be clear if we take examples. Example 1. This equation, rather relation, involving x, y, here a is constant, we mentioned that we cannot express y in terms of x. That is why this relation involving x, y is in implicit form. Now we have to find the differential coefficient of derivative dy dx. Differentiating both sides with respect to x. One thing I suggest my students, you write this statement before starting differentiation. You write this statement. Generally we find students don't write, but I say this is not simple operation as you have used earlier, addition, subtraction, multiplication, division, etc. Since this is a special type of operation, you must mention this one while you are going to differentiate. d dx x cube plus y cube at least initially you write the statement. You see, I have written d dx, that is the operation of differential coefficient of the left side is equal to d dx of right side expression. Now we apply the rules we have learned. d dx of u plus v form, therefore d dx x cube plus d dx y cube is equal to, here 3axy, 3a is constant, therefore 3a is taken outside. According to the formula or law, d dx of a into fx, where a is constant, is equal to a into derivative of fx. Therefore 3a into d dx xy. Now this is derivative of the standard function x to the power n form. Therefore, ddx of x cube will be n into x to the power n minus 1, that is the formula. Therefore, 3x square plus ddx of y cube. You see, the function is of y, but we are differentiating here with respect to x. That cannot be done directly. We have to apply here chain rule. That is why I write dy y cube into dy dx is equal to 3a into ddx of xy. That means ddx of product form. Then in case of product form, that is say u into v, ddx of uv will be equal to, you have learned earlier in class 11 standard, u dv dx plus v du dx. I apply that 3a follow these steps. While you are in the learning stage, you must write down these steps carefully. Of 3x square plus y cube, derivative of y cube with respect to y is 3y square into dy dx is equal to 3a x into dy dx plus y, derivative of x is 1, therefore this one. Now we find there are 3 on both sides as a factor. We divide both sides by 3. You do that mentally. Therefore, x square plus y square into dy dx is equal to a into x dy dx plus ay. Now, the next step will be dy dx terms are to be taken on one side. I am taking on left side, or y square dy dx minus ax dy dx is equal to ay minus x square, or y square minus ax into dy dx is equal to ay minus x square. Therefore, dy dx ay minus x square divided by y square minus ax. Students, learner, you follow the steps I have followed. First of all, you write that statement differentiating both sides with respect to x. Then this step, in the initial stage, you must show these steps clearly. Then apply different laws of derivative, already we have learned. Then in this stage, we have taken dy dx terms together. Then dy dx is the common factor. After that, final step dy dx equal to this. This is the answer.